Hello everyone, my name is Tao Fang and this is my experiment video. This is my ZID card, student ID card. So today I will take you through the solar system using Kepler's law with the help of PHET simulation. So now let's come to the first part. What are Kepler's law? Kepler's law describe how planets move around the sun. There are three laws. The first one is the law of ellipses. Planets move in oval orbits. The second one is the law of equal areas. That means planets sweep out equal areas in equal time. The last one is the law of harmonies. The time it takes to orbit is related to distance. So, um, let's explain the first law. The first law tells us that planets orbit in ellipses, not perfect circles. The sun is located at one focus of the ellipses, not in the center. This explains why the distance between a planet and the sun changes as it orbits. The second law explains how fast a planet moves. A line connecting a planet to the sun sweeps out equal areas in equal time. So planets move faster when they are closer to the sun and slower when farther away. The third law shows that the square of a planet's orbital period is proportional to the cube of its average distance from the Sun. In short, farther planets take longer to orbit. This law connects time and distance in very clear way. Um, and this part I will describe the planet and the moon. Here is what happens when a planet has a moon. They don't orbit around each other directly, they orbit a shared center of mass. This point isn't at the center of the planet, so the planet wobbles slightly as the moon pulls on it. This explains the bulky purple path in the simulation. To get a sense of size, we switched to the two-scale mode in the simulation. Each grid square represents 1 AU, the average distance from Earth to the Sun. This lets us compare planetary distance more realistically. I tasted how changing a planet's mass and speed affects its orbit. Different speed and masses result in different orbital shapes and periods. Too faster or too slow, and the orbit becomes unstable or elliptical. Next, I experimented with distance. As I increased the distance from the Sun, the orbit became wider and took more time to complete. Each snapshot here shows how distance changed the orbit. Here is a table of my simulation result. It shows that as distance increases, so does the orbit period. These values follow Kepler's third law: the farther a planet is, the longer its orbit takes. According to the Kepler's law, Mercury is the fastest planet. It is close to the Sun and feels stronger gravity, so it moves quickly. Neptune, on the other hand, is farthest and moves the slowest. These observations agree with both Kepler's and Newton's law. Through this experiment, I learned how distance affects a planet's speed and orbital time. The closer a planet is to the sun, the faster it moves. The simulation helps me visualize Kepler's law better than just reading them in a textbook. It made everything clear and easier to remember. So that's all information about my video today. Thank you for your watching.